it's streaming. I think it.
Is it recording now?
No, it's streaming already.
All right, so everybody hear me? Good. So welcome to the TVGS lesson night. My name is Neori. I will be giving a lesson about physics in video game design. I have a PhD in physics from UAlbany, so that qualifies me perhaps for the physics part, and the games part I'll let you judge yourselves. So, this class will demonstrate some applications of concepts from physics to designing responsive and credible games. We'll have two main parts, basic physics in the Unity engine, which include movement, collision, and forces, and using physics to control your game, which will feature two main examples, platforming and space exploration. So what we have open here is the Unity engine. If you haven't used it, it is very well recommended for its advanced physics engine, and there's a very good reason for that. It's possible to create a very nice game without a fully fledged physical engine, and games have done that for many years. But there's more and more of an expectation of realism from players. So it helps to have an engine that can provide that realism by simulating parts of reality. More or less enough for the players. And thinking about about problems in your games like a physicist, breaking them apart and finding what the important parameters are can be very useful. And if you focus on the right models, you will avoid taxing your computer with unnecessary simulations. So let's start with the bouncing ball. Now I'm going to illustrate some concepts with this because in a lesson a few months ago, Jason Harlow showed a bouncing ball, and what he showed in Blender, which is a rendering and 3D modeling engine, is how to get this kind of ball bouncing around with a given path. But here you don't have a path, and yet the ball bounces. So let's look at that. Hopefully. Yeah. So that's actually not a bouncing ball. That is because of something that we'll get to in a bit. Let's see, let's make it 0.6. So the nice thing about Unity is you can go back into the editor and play around with some parameters, and we'll be using that a lot today. So we don't have a specific path for the ball, and yet the ball goes through path. And you already noticed that when I changed this thing called the physics material, which I'll talk about in a bit, the path changed. And the idea here is that instead of having a path set out for the ball and then changing it at various points to get something that looks realistic, Unity is actually simulating a basic variety of physics for the ball as it's moving. And that is very nice because then we can change parameters for it and to be able to express what we want with this bouncing ball and with physics in the game generally. So let's look at this ball's movement. What are the important elements of its behavior? So it starts from a point and goes to the right and downwards. Let me just go to that and pause it there. So that's not very nice. But it goes to the right and downwards. Then it goes and hits the floor. It bounces back up. Gets to an apex, and starts something that looks a lot like its beginning except lower, and then it keeps that going until it stops and rolls off. So if you look at it a few times, you'll notice that the horizontal movement is more or less regular. I mean, it's kind of distorted by the camera, but basically, if you look at a horizontal movement, it looks pretty uniform. It's just moving to the right at a certain speed. The vertical movement is actually very irregular. If you just look at the up and down axis, you see that it's going down and accelerating, and then it bumps, and then it goes up and down and up and down and up and down. And if we, let's see, move this fellow over here, you'll notice it'll be even better. Even if you're looking at the vertical movement, there's the more or less smooth acceleration, and then there's the bumps. So, what is the ball actually doing under the hood, inside of Unity? This is the ball. Pretty straightforward. So it has a bunch of these components which express its behavior. It has a transform, and that says where it is. We can move it around in the scene by changing these little things. Let's see if we can. Yeah. These are the adjustments. You can make those with the mouse by dragging, or you can just write that in like I did earlier. And that's very important physically, obviously, and geometrically. There's a renderer, which and a mesh filter and all that stuff, which tells us how it's going to look in the scene, and that's very important geometrically and in terms of how the user perceives your game. There is the sphere collider right here. Hold on, let's look at this from the scene view. Yeah, so this is the scene view. That's very nice and allows you to take a much more varied look at your scene from a lot of angles. So, yeah, so that's the circle collider. That deals with collisions, in this case with the floor. And finally, there's this really important part that's it's very important, so I put it up here. It's the rigid body component. And that has the mass, and it has all these things called drag and angular drag. It's the one where I can decide whether to use gravity or not. So if I don't use gravity, something interesting happens. It just moves in a very unrealistic way because we're used to gravity. And it has a bunch of parameters that aren't that important. There's freezing, which is when you're constraining your game, you might want to, for example, constrain it in the Z direction because you're not expecting any Z motion, and that will reduce calculations. And you'll notice I have another thing here. It's kinematics. It's a script I wrote because currently rigid body doesn't show you these things. If you write a script, you will be able to look at rigid body as a more programmatic component. And then it has a velocity, it has an angular velocity, there's a maximum angular velocity you can play around with. But rigid body currently doesn't show this. And this is actually very important if you're looking at it as a physicist because the velocity is the initial condition, as we call it. It's something that you can give a physical body when it starts, and then that, assuming you have a good physics simulation, that tells you how it's going to keep moving after that. So, now let's look at this. This is the velocity. It's 3 in the x direction, 0 in the y direction, 0 in the z direction. So, what will happen if I switch this with -3? Anybody want to guess? Yeah, so it's going to go in the other direction, which is, for us, somewhat unfortunate because our camera isn't going there. So there we go. So this property, which is very important for how things are going to start moving in your game, needs this script that if you're interested, I can just send you. It's not very long, and it makes sure that you can actually do this in the inspector. So yeah, so that's very important. That's in this case, without having movement in the y or z direction. This is basically, this only affects the horizontal motion. So it starts out with horizontal motion. It doesn't have any vertical motion, right? Now suppose we added velocity of 8. have an 8 component in the going up. Well, I still have that in minus, but as you can see, it looks like it's in the middle of a jump. So that's clearly not what you have when you're starting out a jump. So somehow you get to a point where you're there, and that's through gravity. So like I showed before, if you don't have gravity, it's just going to move. It's in fact going to move in whatever original velocity it had until it collides with something off screen. Every rigid body starts with gravity because it's expected that that gravity is an important part of a physical world. It's basically something we consider as obvious until we might not think about it. But all we have to do is turn this off, and you can see how weird the world would look. Or you can look at some program about people in space, and you see them acting that way as well. So for this individual ball, we can decide what the velocity will be, right? And then we see a bunch of interesting behaviors. Gravity can also be adjusted, but you'll notice that there's no number by gravity here. You can either use it or not use it. And that's because that's a force that acts on everything in the scene. So if you go to Edit, Project Settings, and get there, Physics, you'll find a bunch of interesting stuff. And one of them is what gravity is. So gravity is none in the x direction, minus 9.81, which is the metric version of the gravitational constant on the surface, and 0 in the z direction, which is farther away. So the assumption is that down is negative y. So we could change this. We could decide that this is going to be really weak. And then the game will be a bit different. Actually, I did this in the wrong direction. So gravity is going up, so things are floating. That is peculiar, but that's not exactly what I had in mind. So suppose you have a game that's on, I don't know, Mars, and you want to have that kind of behavior. This is where you would change it, but you would change it for everything in the scene. So if you decided to create another ball, and let's see if I can easily move this, and you moved it somewhere here, both of them act in this way. You can decide that this one will actually have, starting positive velocity, and maybe go in the negative direction. But in terms of how they feel as physical objects that you're looking at, they look like they're the same copies of the same object, even if they're looking in different directions. And gravity helps make that helps keep that uniformity, like you're in the same world, even though those are different things. So usually you don't play around with the gravity as much. What's that? Let's go back to. Can I reset this? Yes, excellent. Except it doesn't work. So minus 9.81. If I didn't remember that, I'd have to return my PhD. So I think that's a law, right? So gravity is usually uniform, but sometimes you'll have areas where gravity is different and it makes sense. There'd be a game reason for it. For example, some part is under a waterfall, so you're pressed down much harder, or some other part you're floating in water, and this is the best you can do. I would use buoyancy, but if you're trying for simple, you can just create an area with something called a constant force, and maybe change that a bit. But normally this is something that's talking about the environment, while that process just the choice of initial velocity is something that you normally would choose for that you would make for individual things in the scene. Yeah. So let's see. Okay, so obviously this is a bouncing ball, and when I started it wasn't bouncing. And why was that? It wasn't bouncing because the floor, when it was getting into the floor, it stopped there. And what I changed to make that work again was something I'm calling adaptive here. This is physics material. That's what's called a long-term typo by the developers. Strangely enough, in 2D it's called, I think, physics 2D material or physics material 2D, but in 3D it's physics material for historical reasons. So there's several parameters here. So I'm not going to talk about friction just because for scope. I can talk about it later if there's time. But bounciness is the parameter we can talk about. So bounciness basically decides how much of the energy you're coming in with you're bringing in to the collision. Everybody's gonna take out. So if you make it 1, it's like one of those really annoying bouncing balls that hopefully nobody's brought here because that will wreak havoc. See, it's bouncing all the way up. And we can do this, which I did earlier. And so that's sticky, that's all the energy is gone, and it's just the particles come to rest as soon as they touch something, at least as far as in that direction that they collided. Another thing to keep in mind is that you can decide to have a different physics material. So you can decide that the balls are going to be sticky and the floor is actually going to be bouncy. And then what'll happen? I guess we'll see. Okay, so why did that happen? There are other parameters, unfortunately. So if you're combining the bounciness of two particles with different bouncinesses, you need to make a decision of what's going to happen when that occurs. So there's several ways of combining bounces, like with friction above. So you can decide to multiply them. And when you multiply them, when you multiply 0 by 1, you're going to get 0. So that's not very helpful. You can take the minimum, and then the minimum of 0 and 1 is 0. So same issue here. You can decide that it's actually going to be maximum, and this needs to also, how these interact I'm not entirely, but if you make both the maximum, then even though this one has bounciness of 0, the maximum of the two bounciness is actually 1. So these are going to bounce fine, but if had they struck each other, they would have stuck together. So you can create really complicated interactions between particles depending on how their physics materials interact. And let's see. Yeah, so let's look at something else here that's kind of important. So here we don't have that at all, but suppose there's a checkbox here called is kinematic. Now, the floor doesn't have this because I decided to just not give it any physics. So it by default kind of has it acts like it's like this. But basically, is kinematic means that instead of being told by physics what to do, it's told by a script what. So since no script is telling what to do, this is good. So as you must have seen, the ball hit the other ball, and the other ball just didn't move. So it's become a fixture of the environment. So sometimes you'll have parts of the environment that are doing certain movements, but they're programmed movements. They're a door is opening, or you're controlling a character and you want to use kinematics for that. So this is something that you can check, and then physics doesn't act on it. It only acts with physics on other things. which is, you know, this violates the third Newton's law, but sometimes you need to make do to get things to work. So yeah, so if you're having your element controlled by script, and you have a rigid body, make sure that it is kinematic for at least for the time you're controlling it, because otherwise you're going to get weird behavior. So what's going on here? Yeah, so this is. Yeah, so yeah, this is all to do with the bouncing balls. So bouncing balls look and can be several complicated movements. I mean, you could add a bunch of balls here and give them a lot of really weird directions. And let's just do this. So let's move them around. And change the also, so this is 1 and this is 1 and this is -3. You could have a bunch of things doing really weird stuff, a bunch of you know, bouncing balls or whatever, and instead of having to trace them and then decide whether the results make sense for you, you can just let the physics engine do that for you, which is nice, although sometimes it will like you. And you'll notice that you can get really interesting behaviors by just playing around with a few very well chosen parameters. So now, any questions before I move on? Yes.
The bounciness, what happens if you put it above 1?
I don't think it'll allow above 1, but let's check. Let's see. So did we decide that these are all the floor is bouncing, right? Yeah, okay. So I don't think you can do more than 1. Yeah, no. It just it's something you can do with scripts where you enforce a certain range. Bouncing is basically all of the energy. You could hypothetically have just more energy come in, but then you'd have to decide where it goes. So those are basically that's basically the range. Either all of the energy, or I mean, either all the energy is preserved and you get a bunch of bounciness and excitement, or it's 0 and they're sticking together, or somewhere in between, depending on what you're looking for.
So it's basically a transfer of momentum between the two objects.
It's complicated because it depends. Basically, if I'm thinking of this as a physicist, momentum should, even if you're doing really weird stuff, momentum should still be preserved because conserved because it doesn't have anywhere else to go, in a sense, while energy does. So let's just remove all of these and look at that again. So we just have this, and let's hopefully have it. No, I didn't. No, it's doing something not interesting. Okay. So it's bouncing and it seems to be fine, but let's make it and the floor adaptive. As you can see, I can drag the physics materials onto objects, and it'll automatically get it to where they have to be there, which is easier than going over to this. But let's look at the adaptive one. So basically, what happens when you have a bounciness of, say, 0.8? So what you see here is there's two different things happening here. One of them is the bounce gets lower and lower. The other thing is something you don't see. You don't see the ground moving. And as a physicist, that tells me that the ground is acting like something with a lot of mass. We will actually look into collisions specifically in just the next section. and I'll show how that happens. Any more questions about the bouncing ball? Awesome. Sure. It's very, very helpful. Okay, I mean, not sarcastically, it's very helpful. Just not right now. Okay, so now we have a collision. This is, being a physicist, I like to break things apart, so instead of having a really complicated thing, like a bouncing ball, I'm gonna have something really straightforward. Two objects, a background I'm gonna just have to give you a sense of scale. So let's look at these things' components. They're in certain positions in space. They have velocities that are equal and opposite. And you'll notice that gravity isn't working because I don't care about gravity right now and I don't want to talk about it. So this is just to illustrate collisions. And this background is just nothing, as little as possible, just to give you some sense of structure. So we will run this. So this was a completely elastic collision, if I'm not mistaken. So these both have the adaptive material. Yes, so we can play around with that. So, I mean, it's almost completely. Since there's no other forces going on, it doesn't look like anything else is happening, and there was just one collision. But it's almost completely. This would be completely elastic, or completely bouncy in terms that don't look like they're from a physics textbook. So so since you're just seeing one collision, it's not as apparent. But suppose we put this down to 0.3 bounciness. So now it's not so clever. But since it's there's no other forces, there's no friction or drag or anything, they just keep going. So that tells you a couple of things. First of all, that's Newton's first law is if no force is acting on an object, it'll just keep on going at whatever velocity it's going. So you can see that here. Now let's start playing around with these colliders. So aside from deciding to play around with the adaptivity, what else do we have here? So we didn't do anything about mass in the previous demonstration, and the reason is that as long as it's gravity, nothing's going to change. At least as far as several things falling beside each other. The acceleration doesn't change. It doesn't change regardless of what the mass is. But what will happen if we take the second mass, which is hopefully this one here? Yes, the right one. And we take this and turn this into 1,000 units of mass, which are kilograms, I think. They should be. Those are the units, by the way, of unity. It's a metric system, which I am very appreciative of because I learned my physics in Israel where we use metric, and I think I would have a hard time with the imperial units. Okay, so I want a guess from the audience of what will happen now that I've made the second collider's mass 1,000 times that of the first collider.
When they collide and go with a lot of mass, just keep going. It wouldn't be affected as much by the force of the collision.
Yeah. So the guess here is from Jamie that the collider which is more massive will be less affected. So let's see. Yep, that is correct. So what happened here is that the collision basically affects you less the more massive you are. Because any kind of force that's acting between these two as they collide is actually obeying Newton's third law. So it's acting on both of them, but one of them is really light, so is moved around a lot, and the other isn't. And if we take this further out, like let's take this to over 9,000 million. Let's see how far it takes it. Yeah, this is 1 times 10 to the 9 is as far as it'll go. So 100 million, 1,000 million. Yeah, 1,000 million is as far, a billion is as far as it'll go, because things get wonky if the mass is too high. So if you do this, yep, it's not moving at all. And what's more interesting is that if we don't change if we keep it at rest, and it's only the other mass that is going to move, we're going to have something very interesting happen. It's as if it's bumped into a floor. It's even though though these are both objects obeying the laws of physics, and there's no kinematic on them or anything, the second object barely moved. And that's something very important for a physicist trying to make something believable. If you want something that's not moving, you need to make it seem like it's really big. So the ground doesn't seem like it's moving. It really is, but it doesn't seem like it's affected by anything but you jumping on it. And that's because it's all connected together and it's really, really massive compared to you. So that's something to keep in mind when you're colliding things and when you want to see what makes sense in terms of things bumping into each other. All right, so this, unlike the bouncing ball, is a bit simpler. So if there's no more questions, I will go to this exciting sounding one. Okay, terminal velocity. Sure, save. Now we have a background, which is, again, just to give a sense of scale and circumstance. And there is this falling thing. And you will notice that it does use gravity. So let's let it fall and see what happens. So it's falling, and it's accelerating, and it's going way off screen. So sometimes that's what you want. You want something to disappear off screen. But sometimes you don't. Sometimes you want something to fall, but in a controlled manner. So that introduces something called drag, because you could just start this off. You could say, oh, I don't want to use gravity. I want, as soon as this falls, oh, did I not add, okay. So, assuming this works, hey, what? No. Okay, so suppose I want to add kinematics here. So this is our kinematics. Suppose I wanted something to fall without gravity. I say, well, I want this in a controlled manner. I want, 5 meters per second sounds good to me. Let's get it going. Say something's walking off a cliff and falls. That was a bit abrupt in the beginning. So, especially if it's going to end up being something like this. It looks weird. It's kind of jumpy in the beginning, and it's not just a matter of of me not using the algorithm sufficiently. It just doesn't, physically, it doesn't quite make sense. You know that when people are falling down, they start off slowly and then accelerate. And if you're looking at a fall that took long enough, then people normally start to stabilize on something called the terminal velocity. So let's see what happens. So now there's no starting velocity. There is gravity, so there's a force that's going to be acting downwards throughout the movement, and then we're going to add something called drag. All right, so that wasn't enough drag. It didn't look like it was changing much. Yeah, so that looked a bit better. And the idea is that drag is a force that acts against your movement anywhere in space. Okay, so this was a bit subtle. Let's make it 0.8. But this was a bit less jittery. It ended up at a nice reasonable speed, but it started out from rest without just jumping. So drag is a very interesting force and very important force. It, as I said, it resists your movement. It becomes stronger and stronger the faster you are. So eventually, if there's some kind of an outside force like gravity pulling you, eventually you're going to end up at a velocity where the force of whatever is pulling you is the same as the force of drag, and then you're going to stop. And that's what's called the terminal velocity. That's the velocity with which you're going to hit the ground eventually, if it is gravity. Hopefully, you're going to find something nicer to run into. So that when you have a character doing jumping around and you want it falling off a ledge, you normally don't want to just start at some kind of a velocity of going down. You want to have something where it's, even though it's a controlled end velocity, it's going to start from rest in a smooth way. And one nice way of doing that is having gravity with drag. And we'll see elsewhere that there's other ways of using something like this. So, that was all very nice, but it's all very physicsy and very descriptive, and I'm running things in Unity, and that's all well and good, but games are usually about people playing, right? There's control, there's agency. So in the second part of this, I'm going to play around with playing around and see how physics plays into that. At least rudimentarily. But before I go to do that, any more questions? All right. So, yes, please save. Always save, and then save, and then use version control. So, what we have here is something I'm calling bad platformer. Why am I calling it that? So we have cylinder of the cylinder and speed lindra, which is just a cylinder on the side. Basically, the question here is, how do you control a character in a platform? So you have a platformer, and you have these things. Flying around doesn't look very exciting. Let's see what else we have here. So, yeah, so let's start with, what's going on here? Yeah, okay. So yeah, starting out, just want to make sure of certain things. Starting out, you can do several things with controls, and these controls have been in games in the more distance paths for the most part. Basically, you could have, something where when you use the arrows, you're just moving something around. And Unity will let you do that, and more or less, as you can see, more or less enforce collisions, although not really. Or you could try and have it be basically giving you speed in the direction you want, but if you want to connect this with gravity, it's not going to work very well. And again, it's not going to interact well with the other physics stuff happening. So let's see. So was I using? Oh, it's very curious. I thought I got rid of this, but I didn't. So yeah, so this is a simple gravity thing that added to that. What if I do this instead? Yeah. Sorry about that. So yeah, that's not working very well. Yeah, so a lot of these things are very wonky. So a way of doing platforming that's okay, let's not save that, is you have an object, you want to control it. I mean, it's nice that everything works with physics, but the player needs to add something in. So what do we have here? We have the cylinder again, and now we're moving it. So when you're moving and you have an actual whole body moving, you start from rest and you're slowly fighting against the urge to stay in one place, and you fight and eventually get to some kind of a velocity, and that's where more or less you walk. And if you want to expend more effort, you run, and so forth. So if you look at that in an abstract way, that kind of looks like terminal velocity, right? Because there's some kind of a force, a motive force that's bringing you ahead, but the faster you go, the harder it is to go any faster, and eventually you settle into some kind of a comfortable or uncomfortable speed depending on what's chasing you. So what happens here behind the scenes, and we'll see if I can easily open this, is that I am using gravity to keep this down, and there's drag, so all movement is slowed whenever you, it slows you down whenever, you know, in position to your force, to your movement. And there's a jumper I'll go into in a while. And then there is a linear force mover. So what happens here is that let's see, edit script. Oh, that's nice. So what happens here is very, very simple. So I'm saying I've made it really general, so you get a certain force from using the horizontal axis, which is again something very nice that Unity does for you and some APIs don't do for you. You have an axis of horizontal movement that can be anything from a joystick or some arrows, and that's translated into some kind of a number that you can then attach to a vector and create movement out of it, or get a direction out of it, instead of having asking a question, oh, was this button clicked? Oh, okay, so I'll add that to whatever movement I was going to do. That's very convenient. So this is really generalizing everything, but basically this is from the vertical axis, the up-down of a joystick or a keyboard or whatever. And basically I have this rigid body, and here you can see the rigid body as a script item, and then you can do all of these nice things like create a script that shows you movement, that shows you what the velocities are, and you do something called add force. And add force is something you want to do usually in fixed update, which is, again, feel free to stop me and ask questions, but basically, Unity mono behaviors or whatever, they have all these things you can override. And if you do, then this gets run every time there's a fixed update, which is every time a physics calculation is made, basically. This is run at the beginning of the scene, more or less, or when the script is loaded. Sorry. And there's something called a regular update, which is once per frame, and that's, if you're doing something physical, you usually want to do something in fixed update if you're making a change like this. So what's happening here is that force from horizontal is some kind of a vector that you as a programmer can decide on. Gets multiplied by the horizontal axis, and that tells you how much it's going to move in that direction that you've decided inside the game space. And similarly from the vertical. So this is add force, which is very important if you want to if you want to translate control from the user to whatever you're to the object inside of the game. And yeah, so that's good for movement back and forth, right? Now a platformer is, you could make a platformer without any jumping. People generally expect jumping, I think. So how do you create a jump? It's not always straightforward. Especially, at least it doesn't look so to me. But this looks kind of like a jump, right? So it's not a lot like moving horizontally. You need not only to have this something happen only when you're touching the floor, but it also needs to have an effect, but it has to stop when you leave the floor somehow. So basically the way to do that, or one way to do that, is, where is that? Here we go. So there's the jumper. And this script is very nice. It's another fixed update. And it has a bunch of weird stuff Oh, I see. Yeah. Oh, okay. So it's a bit involved, and it's wrong, and I'll show you why. But basically, the idea is that you want to know when to jump, right? So the basic idea is if somebody is pressing the jump button, whether they've just pressed it or just released it, or they're just pressing it for dear life. One behavior that's possible is to decide that any of these is a jump thing, and then if you're on the floor, you'll be able to jump. So, so in order to do that, you add a force, but you make it an impulse force, and that tells the rigid body that it's some kind of an explosive force. It needs to be to act in a certain time frame. And then stop. So, yeah, and I have some kind of a collision control thingamabobber here that doesn't work very well, and I'll show you why. So you see I'm moving, I'm jumping. So very nice, it's very nice to see that I can jump in air, because I don't want to do that. If you get the right power up in Metroid, you can get to jump twice, but that's usually not where you want to start. But I made a mistake that I'll have to find eventually. Basically, I can wall jump, which I assure you was not intended. I wrote this specifically for that not to happen. So I'm not going to debug it right now, but basically, sometimes that's something you do want. Sometimes you do want somebody to jump, although you do want it to be, you usually want something magical to happen with that. So, for example, if you've played the more recent Mario games, unlike the ones before that I remember as being recent from being a kid, a long time ago, there is wall jumping, but it's very specific. What happens is, let's see if I can reproduce this here. So this doesn't happen. You actually jump and move. You move away from the wall, and that's it creates a constraint that you have to work with. So it has some kind of internal sense, right? I mean, how are you jumping from a wall? You're pressing against the wall. What does that mean? You're gonna get pressed back. So this isn't very physical, what I'm showing you right now, right? I mean, you're on the wall and you're just jumping up. That seems kind of weird. So, but basically, the way to resolve that would involve playing around with the physics and seeing how to get the algorithms to do the physics the way that you want, because wall jumping can be really cool. Sometimes you just don't want that. Sometimes you want just this to happen. You want somebody to just fall to their deaths if they hit the wall. Sometimes that happens anyway. Sometimes you want to adjust that according to what the wall is, and that can also be programmed. But this looks kind of okay. I mean, it needs some work to make it feel nicer. Another unphysical thing that's happening here. I'm jumping up and then I fall down. That's okay. I'm moving here, I'm jumping, and then I'm falling down. That's fine. I'm jumping here and then suddenly I'm turning in midair. Now, if most platformers I think that I know will allow you to do this, physically that doesn't make any sense, right? Because you're in the air, you don't really have anything to press against, so how are you going backwards? But on the other hand, it really feels very frustrating to jump and then not be able to do anything until you hit something, even though that's a realistic thing. Aside from some things you could do with, if you had wings or something, you could play around with it a bit, but realistically, you expect in most cases that if you do this, then you're done. This is it's sad, but that's life. But so sometimes you allow things to be unphysical for them to be more fun. As much as it's hard for me to say this as a physicist, but even when you're doing physics wrong, you're still using the physics engine, because all of these things are basically saying, well, there's an arbitrary source of force. Don't think too hard about where it's coming from in the game, but it's there for your entertainment. And so when you're designing a game and you're putting physics in, just remember that it should be realistic, but not so realistic that it's not fun. if there's one takeaway from this talk. Okay, so anything about this before I go to space exploration?
Can you elaborate a little more on the difference between an impulse and like the way a force is normally applied, not as an impulse?
All right, so let's just see this. So normally, if you just said something like this, right? I decided I'm going to delete this. So this is just a regular force that's being added in this one cycle, right? This will be compiled, and that's another nice thing about Unity, that it allows you to experiment with scripts, and it will compile things in the background, and it'll yell at you when things aren't running right. But if things are running right, you can just get back to work very soon. So everything seems to be working according to normal, but I'm not jumping. I'm pressing really hard, honestly. So what happens is, if you don't tell Unity that it's an impulse force, it just applies that force, that physics cycle. And there's usually a lot of physics cycles in every frame, and there's, when you're lucky, 60 frames per second, but let's say there's 24 frames per second. So inside of a physics cycle, inside of 1/24th of a second, there's a bit of force being applied. So that's not enough time for there to be an impulse that will move you. That's just not enough time. So instead of you having to calculate how long you would have to apply this force for it to make sense, Unity is very kind and has this switch, which is basically says what kind of force mode you should have. There's other ones. Let's see. Yeah, there's a continuous acceleration ignoring its mass, which is, I mean, this is nice. This is basically a nice way to get to adjust gravity in a specific area. You could do something like that. I think these are new. I don't think I've seen a couple of these, but or I'm just have not been looking at it very well. But yeah, so that's the base thing is. This is a force, continuous force. This is the ordinary thing. Impulse is when you jump, or there's an explosion, or someone's being thrown, or something. You want that to be an impulse, so that Unity knows and automatically takes care of this for you, which is one of the things it's known for. Now, sometimes it takes care of things in ways you don't want it to, and then you start having to dig into getting things to work the way you want. But it has a lot of power if you know how to use it. It still has a lot of power if you don't, but then bad things happen. All right. Any more questions? Okay, so last but not least, space exploration. So this is a very terrible space, and I do apologize, but let's look at this. So let's say you want to have somebody with a spaceship traipsing around space. It looks even worse than the scene viewer. You want somebody to be traipsing around. So there's several ways of doing that. So physically, what would happen if a spaceship is flying in space and you're applying some kind of a force? First of all, you have to make sure you're not using gravity, because even though there is gravity in space, right? There's gravity everywhere. Space-time is suffused with gravity. Usually where your spaceship will be, gravity isn't something that's just going in one direction. It's something that's attracting you to specific points, and it gets more complicated, and I don't want to get into it right now, although I could, but basically it gets a lot more complicated. But you definitely don't want Unity's default settings for that, because you don't just want to fall in the minus y direction for no reason in space. So let's suppose we just had this thing, and the controller I have here is linear movement, except now I have the horizontal turning into x direction and the vertical going to y direction. So it's moving and there's no jumping, because there's really nothing to jump from. So yeah, so we're in space and I'm accelerating, and whoa, okay, well, hold on. So this is more, well, I'm somewhere far away. But this is a lot like how Asteroids, the very old classic game, works. Except it has wraparound. And why does it have wraparound? Because what you've seen just now. If you just have something that's accelerating and you have to decelerate to come to a stop in relation to what you're looking at, which is what really happens in space, then it's going to be, there's several ways of dealing with that. One of them is, again, wraparound. So you can accelerate, but you're just going to get to the same stage, which is nice, but it can be kind of strange and very constricting. It doesn't feel like you're. I mean, you get to the point where you're zipping around left and right, but you don't get as much of a sense of you interacting with what's in front of you. The other option is to have the camera just chase this around, right? You can have. Let's do it even simply. This is something nice you can do in Unity. Let's make the main camera a child of the spaceship, so it'll go wherever the spaceship goes. And I'm going to just move around. And all the field of space, the stars are gone. Now that's laziness on my part, sure, but that points to another problem. And that is, okay, so if you want people to just be moving around all around space, you need to have things happening in space. No Man's Sky just came out and they have an amazing way of dealing with that. Or so I hear, I haven't played it. But that requires some thinking and it requires some work, and maybe that's just not that's not the game you want. You want a game, say, where somebody's exploring this particular part of space. Like there's something here. There's a planet here that's dangerous or exciting or both. So one way of doing that might seem like cheating, and honestly it is. Everything almost in games is you're cheating on your level because you can't simulate reality for people entirely. But what you can do is say, well, when people say they want to go left and they want to do it physically, they don't really mean they want to accelerate left. They don't necessarily mean exactly what a spaceship would do. So what we can do is add drag. And like with falling in terminal velocity, once you add drag, you accelerate and then you get to a certain speed, right? And then you stop. And then you start, and then you stop, right? And then if you're more talented in animation and such than me, you can have an animation that shows the reverse thrusters slowing you to a stop whenever you get there. Or, you get to your terminal velocity, your thrusters get cut off until you're doing some maneuvering and so forth. So you can make it apparent in the world why this is happening. But in terms of gameplay, you know why it's happening. This is to make this area seem fun to the player, seem like this is where they're exploring. And the controls, it's to make the controls do what you expect the player to do if they're exploring this part of the galaxy. So, so that's again, I really, I'm kind of a drag, but I kind of like the drag as a force. It's really, it can do many things for you if you know how to use it. There's also angular drag, but that's for angular movement that I wasn't going to go into it here. So that's the second control scheme and how it relates to physics. Any questions about that? All right. So just to conclude, basically mainly the talk. So we started out playing around with physics happening in the game space. Say whatever. Which was all about just things happening. So we had a bouncing ball, which is going to be very exciting, but if you're playing, you want to play more than just putting balls in place and letting them drop and bounce around. Collisions are also very nice, but in themselves they're maybe interesting to look at, but they're not necessarily, they're not in themselves enough of an interaction to be interactive. But all of these illustrate various parts of physics. And then you can use these parts of physics to either do platforming really badly or start making platforming a bit better or you can explore space, or you could do drag and drop stuff, which I dropped because I could not get it to work properly in 3D, because I will commend Unity for having really interesting 2D physics tools, and I'm hoping that they'll take some of those tools and port them back into 3D, because there's a lot of really interesting stuff you can do with spring-like objects and so forth. But as far as things that I more or less understand in how Unity does 3D, these are the main things. And yeah, so I hope you will be using physics in your games. And I thank you very much for your time. Any additional questions?
I was curious, you mentioned you heard No Man's Sky. It's like an interesting way of handling movement or gravity in space.
I mean, it's not necessarily dealing with gravity. I mean, like I said, I've seen some people play it. I haven't played it myself. But the idea is basically, one way of dealing with this is saying, okay, in the scope of a planet, I'm going to have gravity, and I'm going to move around, and I'm locally going to have some just gravity pulling me down, feeling like I'm on a planet. And then you have something that acts kind of like how you would be in a plane inside of a planet until you get to space, and then it starts acting like space, and then it's more or less like the first thing I was showing, except that the scope there is huge. So you have all these objects all over a solar system, and you have solar systems all over the galaxy. So if you're using scale to decide basically that you're having slightly different games at each scale, then you can make this kind of thing work. But I don't know exactly how they make it work. There's some kind of crazy procedural generation thing, which is probably going to be really cool to look into when the NDA is off. Or if they ever publish it, I don't know. I hope they patent some of it, because then in a few years we'll be able to read about it now and maybe use it in a few years. But yeah, that's one thing to do. But they could even, I mean, they could even have just the space exploration part without really doing any of the actual going into a planet, and then it's just a matter of having a lot of solar systems, a lot of galaxies, a lot of stuff to go to. There's also a lot of emptiness, so you can, I think, jump between solar systems there. You don't necessarily have to take the whole trip at a certain velocity or whatever. I hope. But it's a matter of deciding how much of a scale you want and what you're willing to build. If you're like me and you're trying to start small, then you want to limit the ways your player interacts so that they're not dropping off the edge of what you were trying to what you have planned for them. I mean, they might enjoy finding glitches in your game, especially if it's a really famous game, and if you go after the edge, you can jump over levels by writing memory directly by moving your character. That's really cool. But in terms of a game working as it's designed, it's a bit of a one situation. Yes.
I just have a question. This is actually going pretty far back to just the rigid body.
Yes. Any specific one you want to look at?
Yeah. Oh, I have a question about the kinematic option.
Oh, okay.
That if you choose the kinematic option on an object, it then follows the rules of like a different script.
It basically, once you've made it kinematic, it's no longer having any forces applied to it. No forces, no velocity. It doesn't really use the physics itself. All of its properties are used by other things. So if other things want to know, are crashing into it, they'll know how the colliders work, and they'll act accordingly. But it's just going to stand. It's just going to be there unless you have a script removing it. And then if you have, let's see if we can do this. So if you have something that's say a bit higher, a bit more higher, and let's say it's just going to be here. So yeah, so this velocity thing, I mean, the is kinematic thing is a bit is a bit misleading, because oh, I forgot to, okay. So it's a bit misleading because kinematics has to do with velocity and such. So it would seem like, well, if you're setting the velocity here, why isn't the kinematic thing working? Well, by is kinematic, the unity means it's script driven. It's not driven by the physics. So yeah, so this just dropped down and it got stuck. If I move it slightly to the right, might do something more interesting. But yeah. So sometimes you do want to use interesting things that the physics subsystem has for you, but you don't want the thing to be doing anything because of that. One thing is, for example, an example that Unity uses somewhere in the API, the Unity people use somewhere in their API, they say, well, sometimes you want to move a character and then suddenly it gets killed. And then you want ragdoll physics to control it and for it to fall down as if it's suddenly feels mortal. So inside of Unity, that would mean that you would be using is kinematic as long as it's moving, and you'd have to deal with making that movement look realistic, even though you're moving it with scripts. But then once you get hit or you fall asleep or whatever, you click programmatically click the is kinematic checkbox. It's off, and then gravity starts, and all the other physics start having effects. And sometimes it makes sense, and sometimes it's you need to be a bit more subtle about that too, I think. But yeah, that's what is kinematic does.
So if I were to choose the kinematic option of the body, right, and assume the other aspects of the other option, drag and gravity and stuff like that,
It will have no effect because it's basically, it's just drag is something where the question is, okay, how fast is this thing going? This is how much it's going to accelerate, but it's not accelerating per se. It's not accelerating according to the laws of physics. It's accelerating according to where you wanted to move it. It's always moving. Okay, so one way of thinking about it is an object is moving or staying still, and that's kinematics in the sense that it's doing something in space, but it's not doing it in reaction to any physics going on. It's not doing anything dynamic in that sense. It's not. It doesn't care what forces are going, or it does something of its own accord in terms of forces, but doesn't use the physics engine that Unity provides. So, in that sense, it's kinematic. It has a velocity, it has an acceleration, because you can always measure velocity and acceleration for your body, but it doesn't use these as parameters in its movement. It's something that comes out of something entirely different that it's programmed. Sure. All right. Anybody else?
I was just curious if there were any other topics that you would kind of cut out for time, or like if people were to continue on, and if there are any other good things that are interesting to look into.
Okay, so I have a bunch of extras here. For the most part, they're kind of, say whatever. Some of them are kind of weird. So there's something called a rigid joint, which is one of those joints that they're an interesting physical thing that you can have connecting two pieces, and then, so for example, these two are together, and one of them has a fixed joint connected to the other, and I put brake force at 100. So this has gravity working on it, and these don't have gravity working on them. So if I did that correctly, so if you do that, see they're just moving together. But if you reduce the brake force to 10, let's see if this works. See, it's created an applied force between these two objects that was strong enough to break them apart, and that's I haven't had enough chance to play with it, so I didn't want to go into it too deeply. But if you want to create, say, a wall made of bricks and want them to break physically, you'd have them. One way of doing that is having them be connected together with rigid joints. Also have the torque thing at a reasonable value of like 10. And torque is an angular force that I really didn't want to get into angles because rotational physics gets it's just a long thing to work. It's something that takes a while to explain. Yeah. Yeah. So they're breaking through. They're breaking. It doesn't really matter. And another thing you can do is say whatever. You can have if you want your character to be a bit more realistic. One thing you could do is break it into two parts, and then have it react in a spring way. So there's something called a spring joint, where the head, I think, yes, it's a spring joint. What happens is there's a certain distance that it will try to keep between the two objects, and if it's not there, it'll apply a corrective force to get there, and it basically acts like a spring. And that's and you can control how springy the spring is and how much it damps, and also a range where it doesn't work if you want some stability. And you can also get broken like other things. So the main idea is that if you want something to be falling down, and like you could model a person as having a couple of these things connected by springs, and when they're falling down, they're settling into standing. But again, it's not something I've used as much in this context, so I didn't want to pretend to speak about it in a lot of authority. And the drag and drop thing here, it doesn't work the way I was expecting it, because in 2 dimensions, what you can do is you can take this thing and you can say, okay, I'm connecting this thing by a spring to a random point in space. And then it's going to just jump around this point in space. And then you can say, actually I want to move that thing with my mouse. And then you can have something jump towards wherever you have your mouse, and that can create a physically interesting drag and drop interface. And that's what I use in Plane Defensive, my well-known to me video game. But like I said, in 3D, I think there's also a matter of the algorithms being a bit more complicated in 3D. I'll have to look into it, but basically you don't have exactly that functionality at least built in, so I'd have to look into it a bit more. But it's really nice. You have all these tools and you can use them in a lot of really weird ways if you're inclined to. And then them being physical objects, you have parameters that can make sense if you dig into it. And then the important thing is also that you have these behaviors, and then since it's a physical behavior, when something unexpected happens, the result doesn't look completely weird. So I wasn't really careful about that in a previous version of Plane Defensive, and what happened is that people would drag things too fast and then just push things across walls and stuff like that, which is not, again, I mean, sometimes it's what you want to do when you're trying to glitch a game, but usually if you're designing a game, you're usually trying to avoid glitches for the most part. So yeah. All right, so if that is all, then thank you very much for joining me for about an hour of physics, right?
So thanks to Klil. One more round of applause so as those of you who've been here before know, the last thing that we do on Muscle Night is we do pass the hat around.